Alright, so first for our power rule, if I have x to the nth power, then when I take the derivative, I'm going to bring that n down, and then I'm going to take away 1, so then I'll be n times x to the n minus 1. So if I had a coefficient, right, let's say I had a 2 right here, you would just have the 2 times the n. The coefficient would just stay, it would get multiplied. Do not try and use the subtract 1 unless it is x to a power. So if I have e to the x, right, I would not subtract 1 because that is not x to some power. Product rule, so when I have two functions multiplying, the derivative is just u prime v plus u v prime. Quotient rule is going to be low d high minus high d low underneath the low squared goes, like that. Chain, when I have one function inside of another function, the derivative of the outside, leave the inside alone, then multiply by derivative of the inside. Horizontal tangent line, so a horizontal line we know has a slope of 0, which means I find my derivative and set it equal to 0. If I want to find the tangent line, first I need my point, which is just going to be x and then like f of x. And if I also need my slope, the slope would be my f prime at that x value. And we plug into the equation of a line like this. Average rate of change is just slope between 2 points, so that would be rise over run. The change in y would be f of b minus f of a, and the change in x would just be b minus a. Instantaneous rate of change is your slope at a point, so that's just going to be your derivative at x equals c. Derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of secant is secant times tangent, derivative of cotangent is negative cosecant squared, derivative of cosecant is negative cosecant cotangent, derivative of e to the x is just e to the x, derivative of natural log of x is 1 over x. Now careful with this, because derivative of e to the x is e to the x. If I have derivative of e to the x squared, that would be e to the x squared, and then you would have to multiply by derivative of the inside. Same with I had natural log of cosine, right? If I want the derivative of this, it would be 1 over cosine, but then you would need to keep going with derivative of the inside. Here, I've got the limit as x approaches, or h approaches 0. I've got f of x plus h minus f of x. This is the definition of the derivative, so this just means the derivative of f of x, so it's the same as f prime of x. Here, same thing, but now I'm evaluating it at c, so this is derivative of f of x at x equals c, so that would be like f prime of c. Differentiability, so first it has to be continuous, and second, the limit of the derivative has to be the same on either side. So continuity, the limit of the function is equal, left limit equals right limit equals function value, and differentiability, the limit of the derivative left and right has to be the same. Derivative from a graph is just slope, which is rise over run. F double prime, y double prime, and the d second y over dx squared. These all just mean second derivative. That means you would find like your f prime slash y prime, and then you take the derivative of that. If I want to approximate something using a tangent line, first you have to find the tangent line equation. And then once I have the tangent line, then you plug that value into the tangent line. Derivative of the inverse, so f inverse prime is just 1 over f prime of f inverse. Cosine of 0, so here cosine is 1, cosine at pi is negative 1, cosine of pi over 2 is 0, cosine at 3 pi over 2 still 0. Sine at 0 is 0, sine at pi is 0, sine at pi over 2 is positive 1, 3 pi over 2 is negative 1. Cosine of 2 pi, that's back here, that's 1. Cosine of 3 pi, 2 pi, 3 is 1 more, it's back at negative 1. Sine of 2 pi is 0, and sine of 3 pi is 0 as well. And then natural log of 1 is 0. That is something you need to know. Alright, I've got a function h, I've got the graph of g and g prime, or sorry, not graph, table, and I've got the graph of f. A, I'm asking to find the slope of the line tangent to the graph of h at x equals pi. So that's just saying h prime of pi. Before I find h prime of pi, I just want to do h prime of x. So I'm going to take derivative. These two are being added, so I just take it one at a time. Derivative of sine of 3x. This is a function inside of a function, so I need to use chain rule. So derivative of the outside first. That's cosine. Leave the inside alone. Then I multiply by derivative of the inside. Derivative of 3x would be 3. Plus, same idea, chain, because I have cosine inside of natural log. So derivative of the outside. Natural log is 1 over. Leave the inside the same. And then multiply by derivative of the inside. Derivative of cosine is negative sine. So there's my h prime of x, and now I need to evaluate it at pi. So this is cosine of 3 pi times 3, plus negative sine of pi over cosine of pi. Cosine of 3 pi is back over here, that's negative 1 times 3. Sine of pi is 0, so it doesn't matter what it's divided over, it's 0. So your answer is just negative 3. That is the slope of h at x equals pi. Now I want to actually write the equation of the tangent line at this value. So I'm going to have y minus slope x plus 1. Let's find the y value real quick. So r of negative 1 is just plug in. This is inside, it is not two different numbers. This is f of g of negative 1. So I have to do g of negative 1 first, which is 1. So this is just f of 1. F of 1, I go to my graph. This is at a constant rate, so the halfway point, and the x is the halfway point in the y, so that's just 2. So f of 1 equals 2. Now I have my y value. Now I need to find my derivative, so always write your f prime or your derivative in terms of x first. Derivative the outside, leave the inside alone, then times derivative the inside. Now I can plug in negative 1, f prime of g of negative 1 times g prime of negative 1. G of negative 1 is 1, so this is f prime of 1. G prime of negative 1 is negative 1. So now I just need to find f prime of 1. Go to my graph. Derivative from a graph is just the slope. I choose these 2 points. So I'm going down 4 and over 2. Down 4 over 2 is a rise over run of negative 2. And then it's times negative 1, which is positive 2. This is my slope. This was my point. So then I plug this in for slope. There's my equation of the tangent line. Next one, so this is product rule, u prime, v prime. U is f of 2x, v is just g of x, so v prime is easy, it's just, g of x, g prime of x. Now the u prime is a little bit trickier because this is actually chain rule. So I'm still taking derivative of the outside, leave the inside alone, but then I need to multiply the derivative of the inside, so that would be a 2. Now when I write my u prime v plus u v prime, u prime was 2 f prime of 2x, v is just g of x, plus u f of 2x times v prime g prime of x. So this is my p prime equation. And then now I plug in 1. So this is 2 f prime of 2, g of 1, plus f of 2, g prime of 1. G of 1 is negative 3, g prime of 1 is 1/2. F prime of 2 and f of 2. So at x equals 2, the y value, f of 2 is just equal to 0. This is going to go away. And then the slope here, well, this is just a straight line. So I can do the whole thing, or you could say it's the same as before. Some people would prefer to just do it again. If that's the case, then you would just go down another 4. So I'm going down 8, and I'm going over 4, because I'm just using these 2 points right here. And then in which case you get a slope of negative 2. Negative 2 times negative 3 is 6. 2 times that is 12. Here we're going to use quotient rule. So low, d high, minus high, d low, underneath the low squared goes. So this is my t prime of x. Now I plug in t prime of 1. So f of 1 I have already found it is 2. F prime of 1 I've already found it is negative 2. G prime of 1, 1/2. And g of 1 is negative 3. F of 1 is 2 squared. 2 times 1/2 is 1. And then negative, negative, negative is still a negative, and this is 6 over 4. 1 minus 6 is negative 5 over 4. There's your slope. I want the equation of the tangent line, so I want y minus equals something x plus 4. Let's find the y value first. This is just p of negative 4 is negative 4 squared f of negative 4. Negative 4 squared becomes 16. F of negative 4, 4. This is the, yep, exactly 1, so f of negative 4 equals 1. So this is 16. Now I need to take derivative, always write it in terms of x first. So this is going to be product rule, u is x squared, u prime is 2x, v is f, v prime is just f prime. So this will be 2x f of x plus x squared f prime of x. Plug in at negative 4. 2 times negative 4 is negative 8. Negative 4 squared is 16. F of negative 4, we just said, was positive 1. Now f prime of negative 4 is going to be the slope. So I'm going to go here. I'm going to use these 2 points right here. I'm going down 2 and over 2. Down 2 over 2 is the slope of negative 1. So then I've got negative 8 minus 16, which is just negative 24. That is my slope. So I'll plug it in right here. And that's my equation of the tangent line. The second half of the video will be up later. Please make sure you're prepared for response. Bye.